All right, so we're going to talk about the leading coefficient test. And the leading coefficient test is used to determine the end behavior of the graph of a polynomial function. Okay, so we are going to use the coefficient test to determine the end behavior of the graph of a polynomial function. So it says here, as x increases or decreases with that bound, the graph of the polynomial function eventually rises or falls. So how we would use the leading coefficient test is we're going to look at the first term of that polynomial function. So here, this is our former definition for a polynomial function. We're going to look at this a sub n times x to the n power, where a sub n, the subscript of n, is our leading coefficient. This is our leading coefficient. And then our variable n is the degree. So we're going to have to look at the leading coefficient and we're going to have to look at the degree. So let's look at the two rules. When it says when your degree is an odd number, it says for n odd, meaning your degree being an odd number. When the leading coefficient is positive, okay, so let's underline that component there. When the leading coefficient is positive, whenever you have an odd exponent, the graph falls to the right, falls to the left and rises to the right. So they're going to be in opposite direction. It says here, if the leading coefficient is negative, the graph rises to the left and falls to the right. So we're looking at the end behaviors of a polynomial function. And if you notice, you have a diagram that determines um, when the degree is even or odd and how your end behaviors will look like, what they will look like whenever you graph the polynomial function. Okay, so an easy way to remember this, when the degree is an odd number and when the leading coefficient is positive, the end behavior to the right should be in the direction of a positive, going to positive infinity. Okay, that's one way to remember this. Here again, when the degree is an odd number, you're going to have your degrees are going to be in opposite direction. So when it's positive, look at the far right in behavior, it should be in the positive direction. When the leading coefficient is negative, here again, you look at the graph to the far right, and it should fall, going in the negative direction. Now, for when we have a degree that is even, when it is even, it says if the leading coefficient is positive, the graph rises to the left and rises to the right. So they're going to be in the same direction. They're going to go up in the same direction. Okay. And then if the leading coefficient is negative, the graph falls to the left and falls to the right. So both are going to be, end behaviors are going to be falling to the left and right. Okay. So the end behavior, just for definition's sake, our end behavior is the behavior of the graph of a function to the far left or far right. Odd degree polynomial functions have graphs with opposite behaviors at each end. N degree polynomial functions have graphs with the same behavior at each end. Okay, so let's do some examples. Let's move this over some. Here we go. We just want to determine the end behavior given a polynomial function. So for example A, we have a function of f of x is equal to negative x to the 8th power plus x to the 6th. So we're looking for the degree that's the highest of that polynomial function. So our degree here is 8, the number 8. And 8 being an even number, therefore our leading coefficient, so we're going to look at negative x to the 8. I'm going to put LC for leading coefficient, is negative 1. So we have an even degree. So when we have an even degree, okay, your end behaviors will be the same at the end. So since our leading coefficient is negative, then our left end behavior is going to fall and our right end behavior is going to fall. It's going to be in the same direction. Let's do another one. We have here f of x is equal to 11x cubed minus 6x squared plus x plus 3. What's the term that has the highest degree? Our first term here. The degree being 3, and 3 is an odd number. Therefore, our leading coefficient for 11x to the 3rd power is 11. Okay, and it's positive. Positive 11. Therefore, we have an odd degree, and that it means that the graphs will have opposite behaviors at each end. Now, since our leading coefficient is positive, the easiest way, you know that they're going to be in opposite direction, but the far right end behavior should be in the positive direction, therefore, or must be in the positive direction. Therefore, the left end behavior is going to fall to the left because they're going to be in opposite directions. We have here examples. C, f of x is equal to the quantity of x plus 4 to the 6th power. Okay, now imagine that you took this quantity of x plus 4 to the 6th power and multiply x plus 4, the binomial, 6 times. So you're saying x plus 4, x plus 4, x plus 4. So what's going to happen? Your highest degree, because this is raised to the power of 6, is going to be 6, the number 6. And since the number 6 is even, we know that our end behaviors are going to be in the same direction. But what will be the coefficient? So if we multiply x 6 times, then you know you're going to have x to the 6th power. Therefore, our leading coefficient is going to be a positive 1. Okay, so 1 is going to, and it's positive. So since we have an end behavior that's going to be in the same direction and is positive, both the left and the right end behavior will be in the positive direction. And D, we have here -4 x to the 5th, or let me write this out. Let's say g of x, let's give this function a name, g of x is equal to -4 x to the 5th times x minus 1 squared times x plus 5. Now this is a bit tricky because we can't say that the highest degree to this would be 5. Because if we were to multiply this out, okay, meaning we're writing the quantity of x minus 1 squared, we're going to FOIL that. That means the highest degree to this at this point is going to be x squared, because this would be x squared minus 2x plus 1. Okay, so you do not have to multiply it out, but let's look at, since we have all factors here, this is -4 x to the 5th times the quantity of x minus 2 squared times x plus 5. Let's look at the exponents to the variable, or to each quantity. Let's say that. So our degree for this example will be, we have x to the 5th, then we have the quantity of x squared, of x minus 1 squared. So we have a power of 2. So add 5 and 2. That's 7. And then since x plus 5 is being repeated just one time, we have here 1. So 5 plus 2 plus 1, our degree is going to be 8. And then since our degree 8 is an even number, okay, so we know that the end behaviors will be in the same direction. Therefore, our leading coefficient, if we were to multiply all of this out, our leading coefficient is going to be -4. And then that this being negative, so our end behaviors are going to be going downward. Left end behavior is facing downward. The right end behavior is facing downward. Okay, so we will end with this example, and we definitely will be talking about this leading coefficient test a little bit more in class when I see you next.